All right, let's look at theorem 4, midpoint connector theorem for a triangle. All right, it says this, in triangle ABC, right, let M be the midpoint of AB and N be the midpoint of AC. Then midpoint connector MN is parallel to BC, which is the bottom side, and at the same time the length MN is a 1/2 of the length of the base. Right, so I'll give you a picture proof on this one. Right, so here's the construction. So you have MN. I'm gonna extend it MN in this direction, the same length as MM. So this length right here is going to be the same length as here. Then connect here. Maybe I'll call this guy L. Right? Then because these guys are vertical angles, so we know that they're congruent. So this is congruent to that guy. So we have two triangles that are congruent. So this triangle right here, right, and this triangle right here, by side angle side, so SAS. Right, so by corresponding parts of congruent figure, we know that this is congruent to, oops, sorry, this is congruent to that, which means that this is congruent to that as well. And another thing that we can do is angle, right? So it's kind of hard to see, so I'm gonna just do it. So using that Z property, so here is our Z, right? Using Z property, we know that the angle here is congruent to angle there. Right, and these are already congruent because it's a corresponding side. Using Z property, it's the other way around. We know that the AB is parallel to CL. So by Z property, AB is parallel to LC. Right. Then I'm gonna construct another segment, MC. Right, and we can still apply another Z property. So let's see, here is a Z property. Right, this time we already know that AB and LC are parallel. So this will give us the congruent angle here. Let's see here. So this is congruent to that guy right here. So it's right there. Right? Then we can look at this triangle. So here's a triangle here, and here's another triangle here. Those are congruent triangles using side angle side. This side is in common, right? So these are congruent, right? So that will give us the angle here. Say angle here, let's what's the notation? Maybe angle here is corresponding to this angle here, congruent, right? Then we can use another Z property. So let's see, I'm running out of colors. So here we are using a Z property, right? This is Z property, right? Oops, Z property here to show that MN or ML, doesn't matter, is parallel to BC. So we get the first part. So we know that MN and BC are parallel by Z property. I'm using a Z property here. All right. And the lengthwise, if you look at MN, right, MN is 1/2 of ml. Right, because of the construction, we made sure that it's the same length here, same length there. So ml is twice as long as mn, so 1/2 of that would be the same as mn, right? But remember that the ml corresponds to BC, so it's the same length because it's a corresponding parts of congruent figure. Then we're done. So we got the second part. Right? So in a triangle ABC, if you connect the midpoints together, the length is going to be 1/2 of the third side, and the midpoint connector is always parallel to the third side. All right, that's it. I hope that this was clear.